Right, our lesson today is to be able to use exponents of 0 and negative exponents. And there are two rules that we're going to be using today as we do that. The first is the rule for 0 exponents. For any non-zero number, anything to the 0 power is 1. The second rule that we're going to be using is for negative exponents, and anytime we have a negative exponent, it is simply equivalent to the reciprocal of that value. So for any integer n and any non-zero number, a to the n, a to the opposite of n is the reciprocal of a to the n. All right, so let's see what that means. All right, so we'll take a look at some of these activities here. Let's explore the power of 0 using our quotient of properties, or quotient of power properties here. So 5 to the third power is the same as 5 times 5 times 5. All right, 5 to the third power divided by 5 to the third power is going to be the same as 5 times 5 times 5. So we have 3 powers of 5 in the numerator, and we have 3 powers of 5 in the denominator. We all know that when we have the same value in both the numerator and the denominator, right, they cancel each other out. So we'd have a 1 in the numerator and a 1 in the denominator. If we're using the quotient of powers property here, we would subtract the exponents. So 5 to the third divided by 5 to the third is the same as 5 to the, right, that's the same as 5 to the 3 minus 3, right, which is the same as 5 to the 0 power. All right? And each of these then essentially would be the same. 6 to the second power divided by 6 to the second power is the same as 6 to the 2 minus 2 power, right, which is the same as 6 to the 0 power, right? And anything to the 0 power is going to be equal to 1. So when we look at negative 3 to the fourth divided by negative 3 to the fourth, right, that's the same as negative 3 to the 4 minus 4, all right, which is going to be equal to negative 3 to the 0 power, right? And negative 3 to the 0 power we know is equal to 1. And finally, the negative 4 to the fifth divided by the negative 4 to the fifth is the same as negative 4 to the 5 minus 5, which is the same as negative 4 to the 0 power, which we know is equal to 1. All right. Now, let's explore a bit what that means when we're evaluating using powers of 0. 3 to the 0 power times 3 to the fourth power. Well, if we're using the product of powers property here, that would be the same as 3 to the 0 plus 4 power, right, which is the same as 3 to the fourth power. So essentially 3 to the 0 power is 1, right, because anything to the 0 power is 1, and 1 times 3 to the fourth power is going to be 3 to the fourth power, right? 8 to the second power times 8 to the 0 power, that's the same as 8 to the second plus 0 power. We know 8 to the 0 power is 1 because anything to the 0 power is 1. So 8 to the second times 8 to the 0 is going to be 8 to the second power. All right, let's continue down here. Explore negative exponents using the product of powers property. So we have 5 to the negative 3 times 5 to the third, right? That's the same as 5 to the negative 3 plus 3, which is the same as 5 to the 0 power, right? And 5 to the 0 power is going to be equal to 1. All right? Now, this is the same, like we can rewrite this as 5 to the third over 5 to the third, right? Because this is the reciprocal of that, and anytime you multiply reciprocals, you're going to get a product of 1 here. All right, so this next one is going to be the same as 6 squared over 6 squared, which we know is equal to 6 to the 0 power, and that's going to be equal to 1. All right, so let's take a look at some problems here when we evaluate, right? Anything to the fourth, the negative power is its reciprocal. So 3 to the negative fourth power is the same as 1 over 3 to the fourth. Right? And when we evaluate 3 to the fourth power in the denominator, the fourth power of 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1 over 81 would be correct. All right? If we take a look at this next one, our exponents, negative 8.5 to the negative fourth times negative 8.5 to the fourth, right? If we're using the powers of products property here, right, that's going to be negative 8.5 to the negative 4 plus 4, which is negative 8.5 to the 0 power, and anything to the 0 power is going to be equal to 1. Right, this last one here, let's scroll down a bit. Right, this last one, where we have 2 to the 6 over 2 to the 8, that's the same as 2 to the 6 minus 8, which is the same as 2 to the negative 2. We write that as its reciprocal, 1 over 2 squared, and 1 over 2 squared is the same as 1 over 4. All right, so let's evaluate some of these examples here. Problem number 1, 4 to the negative 2 is the same as 1 over 4 squared. Right, 4 squared we know is 16, so that's going to be 1 over 16 for problem number 1. Problem 2, right, that's negative 2 to the, negative fifth power. That's the same as 1 over negative 2 to the fifth power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's the same as 1 over negative 32. Right, this third one, problem 3, we have 6 to the negative 8 times 6 to the 8, 6 to the negative 8 times 6 to the 8. Right, that's the same as 6 to the negative 8 plus 8, which is the same as 6 to the 0, and anything to the 0 power is going to be equal to 1. Problem 4, right, negative 3 to the 5th over negative 3 to the 6 is the same as negative 3 to the 5 minus 6, which is the same as negative 3 to the negative 1 power, which is the same as 1 over negative 3. Problem 5, we have 1 over 5 to the 7 times 1 over 5 to the negative 4. All right, well, this is the same as 1 over 5 to the 7 times 5 to the 4th, right? Because if we have a negative exponent in the denominator, we just bring it up into the numerator, and that exponent becomes positive. So now, this is the same as, let's continue this, right? This is the same as 5 to the 4th over 5 to the 7th, which is the same as 5 to the 4 minus 7, right? And that's going to be 5 to the negative 3, which is 1 over 5 to the 3rd. 5 times 5 is 25, times 5 is 1 over 25, 125. So 1 over 125 for that one. All right? And then this last one, let's copy that. Problem 6. We have 4 to the 5th times 4 to the negative 3 over 4 squared. All right, this is going to be, when we multiply powers the same base, we add the exponent. So in the numerator, that's the 4 to the 5 minus 3, right, over 4 squared, which is now 4 squared over 4 squared. Right, we know that that's 4 to the 0 power, and anything to the 0 power is going to be 1. All right. Here are some examples where we have to simplify expressions. The key here is that we have to remember negative 5 times x to the 0 power, just the variable is being raised to the 0 power, so that's negative 5 times whatever x to the 0 power is. Well, we know that x to the 0 power is 1, so negative 5 times 1 is going to be negative 5. All right? So let's take a look at some problems down here, and let's get them done. Problem 7. Right, this is 8 times x to the negative 2. Right, that's the same as 8 over x squared, because we bring the negative exponent into the denominator and we make it positive. All right. Now, I did skip a step there, and I probably shouldn't have, so let me go back. Right, I'll put that intermediate step there. That's the same as 8 times 1 over x squared, right? And that's how we go from here to there. All right. Problem 8. B to the 0 times b to the negative 10. We know b to the 0 is 1 times 1 over b to the 10th. 1 times 1 is 1, so that's going to be 1 over b to the 10th power here. And this last one, let's see, we have 6 over 15z to the 9th. All right, let's simplify those z's. So we have, that's the same as what? We have z to the 6, to the 6. Let's erase that. That's z to the 6 minus 9, right? And that's going to be over 15. Z to the 6 minus 9 is negative 3, or z to the negative 3. So that's going to be z to the negative 3 over 15, which is the same as 1 over 15 times 1 over z to the third. A little sloppy with the 3 there, but it's best I can do with the computer. Let's erase that, try that again. Right, that's 1 over z to the third, and that's going to be 1 over 15z to the third power there. All right. Now we continue. I'm just going to skip through that page. We're going to get here. So 1 over 8 to the third. 8 times 8 is 64. And 64 times 8 is 512. So that's going to be 1 over 512. Right? 512. And then 1 over 4 is going to be the same as 1 over 2 squared. Right? And I guess we'd leave it like that. 1 over c to the 5th. I guess, I'm not sure. I guess they want us to write this with negative exponents. So that's the same as c to the negative 5th. This would be the same as, I guess you could say it's the same as 2 to the negative 2. Here we have 3 times 3 is 9 times 3 is 27, so that's 1 over 3 to the third, which is the same as 3 to the negative 3. Normally, though, when we simplify those expressions, we write the expressions with positive exponents, so we probably should leave this one like that one like that, and this one, I don't think we'd do anything with that. So I think we'd leave it there. Alright, so let's get down to some of these examples here. Alright, letter J. That's 3 to the negative 8 times 3 squared. When we're multiplying powers with the same base, we add the exponents. So that's the same as 3 to the negative 8 plus 2. So that's 3 to the negative 6, which we know is 1 over 3 to the 6th power. We're not going to evaluate 3 to the 6th power because that's going to get kind of large. So for K, this is going to be 11 squared over 11 to the 4th. That's the same as 11 to the 2 minus 4. 2 minus 4 is negative 2, so that's the same as 11 to the negative 2, which is 1 over 11 squared. And we can evaluate 11 squared, 1 over 121. Problem I, or maybe, guess that's an L. Problem L, we have n to the 9th times n to the negative 4th. Alright, that's the same as n to the 9 plus negative 4. 9 and negative 4, that's going to be 5. That's the same as n to the 5th power. Alright, and this last one on this page, letter M, b to the negative 4 over b to the negative 7. That's the same as b to the negative 4 minus 7, or minus negative 7. Don't get sloppy there, Pallotta. When we add the opposite, that's negative 4 plus 7, so that's going to be b to the 3rd power. Alright, we'll finish it up here with a bunch of examples, but these go quickly. Alright, so this is going to be 6 to the negative 8 is the same as 1 over 6 to the 8th. This is 1 over negative 3 to the 5th. This is 1 over s to the 9th. This is 1 over t to the 11th. Down here, this is going to be z to the 2 plus negative 3, which is the same as z to the negative 1, which is 1 over z. This is n to the negative 1 plus 3. It's going to be n squared. This is b to the negative 7 minus 5. So that's going to be b to the negative 12, which is the same as 1 over b to the 12th. Here we have, it's going to be x to the 4 minus negative 2. Add the opposite there. So that's x to the 6th power. We continue. This is 1 over 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 1 over 16. This is 1 over negative 5 to the 4th. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. We have an even number of powers, so that should be 1 over 625. This is 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So that's 1 over negative 10 to the 4th. Right, so that is 1 over 10,000. Here, this is going to be 1 over 0.5 to the 4th power. Let's finish it up here. This is going to be 2 to the negative 3 plus negative 4. So that's 2 to the negative 7, which is 1 over 2 to the 7th power. Next, we have s to the negative 5 plus negative 2. So that's s to the negative 7, which is 1 over s to the 7th power. Oops, sorry. Let's close that. Right, this is y to the negative 1 plus 4. That's y to the 3rd. Here, this is 3 times a to the 1st plus negative 3. So that's 3 times a to the negative 2. So that becomes 3 over a squared. Right, that is 3 over a squared. Here this becomes what? 3 to the 5th over 3, which is the same as 3 to the 4th. This is a to the 6th over a to the 4th. That's the same as a squared. Here we have y to the 10th over y to the 6th. Right, oops, that is going to be y to the 4th. And this last one, that's z to the 8th over z to the 4th. That's the same as z to the 4th power. Alright, remember this last row, when you have negative exponents in the numerator, they become positive in the denominator. When you have negative exponents in the denominator, they become positive in the numerator. Alright, hope that was helpful, and we'll stop there.